Hello students, welcome. On our previous lessons, we have finished topic 3, form 3, that's organic chemistry 1. So today we want to proceed to topic 4, and the name of the topic is called chemistry of nitrogen and its compound. Learners, know that this chapter is one of the chapters of the chemistry of nonmetals. Chemistry of nonmetals include carbon and its compound, nitrogen and its compound, sulfur and its compounds, and also chlorine and its compounds. So the way we introduce carbon and its compound is the same the way we introduce nitrogen's compound. Introduction. We say nitrogen has an atomic number of 7 and has an electronic configuration of 27. Hence, it is a nonmetal which belongs in group 5 and period 2 of the periodic table. Remember in form 2, we have seen nitrogen in the first 20 elements of the periodic table. It was number 7. That means it was having an atomic number of 7. Then if we take this 7 and we distribute into the energy level, we are going to have an electronic configuration of 2, 5. 2 will occupy in the first energy level because the first energy level carries a maximum of 2 electrons. Then the remaining 5 will go to the second energy level because the second energy level carries a maximum of 8 electrons. So if we see the electronic configuration of nitrogen, that one can help us for us to know the group and the period to which nitrogen belongs in the periodic table. So we start with group. If you want to know the group to which an element belongs, we are supposed to check the last energy level. How many electrons does that atom or that element has in its atom's energy level? So the way we see, we have 5 electrons. So that means nitrogen belongs in group 5 of the periodic table. And the reason is because it has 5 electrons in its atom's energy level. Then for us to know the period, we have to check the number of occupied energy level that element has. So when we check 2, 5 as the electronic configuration of nitrogen, it has only 2 occupied energy levels. So that means it belongs to period 2 of the periodic table. So we proceed and we are going to say nitrogen exists in air as gaseous element consisting of diatomic molecules. Remember we said there are elements that exist in a molecular form. Such include oxygen, hydrogen, chlorine, and also nitrogen. So we're saying nitrogen exists in air as a gaseous element consisting of a diatomic molecule. That means they're made up of 2 atoms of nitrogen. And we're told about 78% by volume of the atmosphere is composed of nitrogen, making it the most important source of nitrogen. Remember from 1, when we're dealing with air and combustion, we have seen the component of air and also their proportions. And we had there nitrogen having 78.1 as it is percentage, then oxygen having 20.9. So next we are going to proceed to laboratory preparation of nitrogen gas. We are going to start with the laboratory isolation of nitrogen from air. So we are going to use the setup to do laboratory isolation of nitrogen from air. Here we have tap water in or water. Then this water goes into flask A or aspirator A. Then this is the water and we are having air which is expelled out of the container or out of this flask A. Then that air goes into aspirator B or flask B where we're having sodium hydroxide solution, and in the place of sodium hydroxide solution we can use potassium hydroxide solution. So now the air will go through the combustion tube where we're having heated copper tanning. Because we're heating the copper tanning, after that the remaining gases will go through the delivery tube and they will be collected over water, and what is collected mainly is nitrogen. So we're saying in the laboratory nitrogen is isolated from air by first passing water from a tap to aspirator or flask A, as you can see here. So what is the role of this tap water or water? To drive out the air that was in the flask upwards and pushes it to the flask B containing concentrated sodium hydroxide or potassium hydroxide solution, which absorbs carbon dioxide. So here, the role of the tap water or water is to drive out air that was in the flask or that was initially in the flask upwards. Then we're saying and pushes it to the flask B containing concentrated sodium hydroxide or potassium hydroxide solution. So what is the purpose of potassium hydroxide solution? We're saying to absorb carbon dioxide or which absorbs carbon dioxide. So let's just try to see that equation or that reaction for the absorption of carbon dioxide. So here we can have two equations. The two equations is we are having sodium hydroxide solution reacting with the carbon dioxide, giving us sodium carbonate solution and also water. But if the amount of carbon dioxide is more, that means the product, which was sodium carbonate solution and water, will react with more carbon dioxide to form 2 moles of sodium hydrogen carbonate. So we are having these two equations. Or you can write one general equation, and that is you are going to say sodium hydroxide reacting with carbon dioxide, which is a gas. This is a solution. It will give us sodium hydrogen carbonate. Sodium hydrogen carbonate solution. That's the overall reaction. If you don't want to use sodium, you can use potassium. You can use potassium hydroxide reacting with carbon dioxide, giving us potassium carbonate and also water. Then that means the potassium carbonate and water formed will still react with more carbon dioxide to give us now 2 moles of potassium hydrogen carbonate. The reason why I'm saying this is the overall reaction is that you can even add these two equations to get the overall equation. So if I just try to add these two equations, check whatsoever you see on the reactant side. If they appear on the product side, they are supposed to cancel out. So we have sodium carbonate solution. We'll go with sodium carbonate solution. We have water. Here we have water. So what remains here will be 2 moles of sodium hydroxide plus carbon dioxide on the reactant side, another carbon dioxide on the reactant side. That's 2 moles of carbon dioxide, which is a gas. Then we are going to get 2 moles of sodium hydrogen carbonate. As you can see, each side we have a common factor, which is 2. So we divide by 2 everywhere. So that means the overall reaction will be 1 mole of sodium hydroxide reacting with carbon dioxide, giving us 1 mole of sodium hydrogen carbonate. So we proceed. We are going to say the remaining part of air. That means in form 1, we said we have components of air. One of them is nitrogen. The other one is oxygen. Then after that, we have carbon dioxide as our third one. Then the fourth one, if you remember, we were having argon or noble gases. 5, we were having water vapor. Number 6, we were having dust particles. Okay, that means in the first part, we have removed the carbon dioxide. Carbon dioxide has been removed from the air by sodium hydroxide or potassium hydroxide, because we are told sodium hydroxide or potassium hydroxide absorbs carbon dioxide. So that means we don't have carbon dioxide. So we're saying here the remaining part of air. Which remaining part of air? We are talking about nitrogen, oxygen, noble gases, water vapor, and also dust particles. Is then burst overheated copper tanning to remove oxygen. So this time we remove oxygen. 2 moles of copper tanning will combine with the 1 mole of oxygen gas, giving us 2 moles of copper 2 oxide. So this is the equation that supports this statement. Okay, we proceed. Next, we are having observation made on the combustion tube, and we are seeing there brown solid changes to black. The reason is that oxygen in the air reacts with brown copper. Remember, the color of copper is brown, to form black copper 2 oxide. That means copper 2 oxide is black in color. And we are saying the residual gas, that means the remaining gas. So what have we removed now? We have removed carbon dioxide, and it was sodium hydroxide which removed the carbon dioxide. We have also removed oxygen. It was copper tanning which removed the oxygen. So here we are saying the residual gas is then collected by our water method. If required dry, it is bathed through concentrated sulfuric acid and collects by the use of a syringe. So that means we're having here a drying agent, that's concentrated sulfuric acid. We can use to dry the nitrogen gas. Okay, next we are saying nitrogen obtained using this method is not pure. Why is it not pure? Because we have only removed the carbon dioxide and oxygen. So we have still impurities like the noble gases. And it is denser than the one obtained through fractional distillation, which we are going to discuss in our next class, and the one prepared in the laboratory. That's the next thing that we are going to do in this lesson, as it contains traces of the noble gases such as argon, xenon, and also neon, even that of helium. Next, we are going to proceed to laboratory preparation of nitrogen gas. We are saying a pure sample of nitrogen gas can be prepared by heating a mixture of sodium nitrite, and ammonium chloride. So this is the setup that we are going to use laboratory preparation of nitrogen gas. We are going to have round bottom flask being heated in a slanting position. Then we are having solution of ammonium chloride and also sodium nitrite. Then we are going to collect nitrogen gas by over water method. So we are going to say ammonium chloride and sodium nitrite reacts to form ammonium nitrite and sodium chloride. And this is the question. Sodium nitrite solution will react with the ammonium chloride solution to give us ammonium nitrite solution and also sodium chloride solution. So we're saying ammonium nitrite is unstable and decomposes to form nitrogen and steam, and this is the reaction. We're saying ammonium nitrite solution, when it is heated, we are going to get nitrogen gas and also 2 moles of steam. So we are saying nitrogen obtained from this reaction is less denser than that isolated from air because it does not contain impurities. So that means this reaction does not contain, or this method does not contain any impurities. But when we are dealing with laboratory isolation of nitrogen from air, here the traces of the noble gases as it is impurities. Learners, that's the end of our lesson today. Thank you.